All right, guys, next thing up. We talked about distances, so the next thing we need to talk about is an objective function. Objective functions are how we use distances. What do you want to do with this distance to define a group? In your objective function, you really need two things. The first is your distance metric, and the second is how you define a cluster or a group. Basically, the idea comes down to you're trying to define capital C subgroups. So let's start looking at this equation a little bit. Now, this equation becomes very important because it defines what we call the k-means objective function, okay? The k-means objective function is really important. It's the basis for everything, so I want to take some time right now and I want to talk about the idea, okay? So what we need to do is we need to say we have capital C clusters. This is something you are going to predefine, and it's something we are going to talk about how to select, okay? Now, what you have to decide, are you going to define a cluster in relation to a central point, like a median or a mean, or another phrase to use is a centroid? Are you trying to classify it as close to a central point, or are you going to say it only matters from the distance between a data point to another? Now, there's other central points that can come into play. The furthest distance between two clusters. You can also measure distances between two clusters. So imagine I have cluster A and cluster B. I can measure them from the closest inside points, which would be my thumbs, the closest outside points, which would be my pinkies, or right in the middle, right in the palm of my hand. So when I'm looking at those type of things, that's what I'm seeing. That's what I'm talking about. And we'll talk about this a little bit more as we go. But the distance metric and the objective function you use and how you define clusters and grouping are extremely important. Now, as you move through this, are you trying to define a centroid? If you're trying to define that centroid, what it does is it creates an average for you, or a center point where you can say, okay, this cluster defined by that centroid is trying to say this because everything's around it. If you use objects that are related to one another, you can go in and start investigating why are these things related or how are they related, okay? Now, questions like this are what leads you to choose your clustering algorithm or what clustering objective function you're going to use. So you've got this idea of distance. Do you use absolute? Do you use Euclidean? What do you use? Now we've got a question of objective function. What objective function? So think of this as you go to the store or you go to a restaurant, you get to build your own combo. That's exactly what this is. You get to build the things that matter in how you view the business problem. That's what this entire idea is. But to do all this, we've got to understand some different things. So let's look at an example where we want to minimize the distance, I don't care what distance we're using, of any data point in the C clusters to the center of the assigned cluster. So what we're going to say is, okay, assign data points to our cluster. Then what we're going to do is we're going to come in and we're going to say for every cluster, I want to minimize the distance between the data point and we're going to say the center of the cluster, center of cluster K, MK. I want to minimize the distance between any data point and the center of the cluster, and this indicator just says, given that Xi is in cluster K. So when you're looking at this and when you're seeing this, what you need to understand is the basic principle of we're trying to minimize distances within a cluster, not between clusters, but within clusters. So we want to create these tight groupings around these centroids. Now, there's a couple things you've got to find, and I want to talk to you about this in a bigger picture from an algorithmic perspective for a second. What that means to us and what we're really hearing about and what we're really talking about in all these situations is I want to minimize, I want to make sure we have nice tight groupings in these clusters. That's what that's trying to do. But the other thing it's trying to do, and the other thing you have to do, is you've got to tell me what cluster the data point belongs to, and you've got to calculate this mean. So there's an algorithm, and there's a lot of different ways to do it, and we'll talk about it as we go through, but I want to introduce it to you. There's two ways to start. We can either just randomly assign the clusters, the data points to a cluster and start there, or what we can do is randomly start the mean somewhere. Pick a point in p-dimensional space and just say, here's mean 1, mean 2, mean 3, mean 4. And then we calculate the distance from the data point to the clusters, assign the data point to the closest cluster, recalculate the mean. After we've recalculated the mean, do it again, do it again, do it again, and iterate clear through. What I just described to you is known as the k-means algorithm, okay? So what you do is you initialize the means. You initialize the capital C means you needed to, all right? These C means, you start off, and then for every data point, you measure the distance to the center, All right. So if you have n data points, you measure n times what? C. You have n times C measurements because you need the measurement closest, or you need the measurement to each centroid. After that, what you're going to do is you're going to say, okay, take this cluster or take this data point and assign it to its closest cluster center. After that, recalculate the cluster center. So it's an iterative process. And once your data points converge, once they don't change cluster assignments, you're set. You have your clusters. So it's a really quick process. From a computing standpoint, it's very, very simple. So much so we're not even going to talk about it that much in depth. But the entire idea that you have behind this, the entire thought process you have is extremely important. The Introduction to Statistical Learning book I've recommended has this algorithm outlined in it. It's a quality book. That's a really good book especially for a data mining class. It's one of my favorites. I have, there's a free copy online. Just go to the author's website and he gives you one of the previous editions, which is fine. Or you can go out and buy it. Overall, it's not bad price considering it has a lot of R examples and everything like that. But from my perspective, just understanding the basics of these algorithms, because it's going to come down, can you use it and can you interpret it? And that's what we're going to see. So we're trying to use this stuff to create insights. And as we move through this, you'll start to see more and more. Okay? I know I spent a long time on such a small slide, but it's something I really need you to understand and I really need you to think about, because this idea is extremely important. It's this idea that, I don't want to say this, it's this idea that your interpretation changes everything, okay? All right, guys, let me know if you need anything.